Welcome to the vignette, What is Meta-Analysis? In a meta-analysis, results of individual studies on a given topic are combined with statistical methods. To better understand why this has advantages over looking at the results of individual studies, let's consider what the two approaches can tell us. Imagine you want to know whether 8-month-old infants can extract word forms from natural speech. This is an important problem to solve for infants. Natural speech, if you listen to it, does not have pauses between words. And infants need to accomplish the task of segmenting out individual word forms from these strings of speech. Now let's look at 2 out of many studies that have been conducted on this topic. Individual study 1 finds that yes, infants can extract word forms at 8 months, while study 2 does not find evidence for this. With the information we have so far, it is difficult to say why these studies come to different conclusions and whether one of these studies' conclusions should be weighted higher than the other. For instance, study 1 could be a false positive or study 2 a false negative. One thing meta-analysis can be used for is to look for moderator variables. For instance, in this case, it turns out that study 1 was carried out with American English learning children in the US, while study 2 was carried out with Dutch learning children in the Netherlands. Of course, it is hard to say from these 2 studies alone that infants' native language was the cause for the diverging results. However, putting together all studies on one phenomenon allows us to make better generalizations on the impact of moderator variables. Still, the point about the native language effect could have been made by means of a qualitative review. Crucially, though, meta-analysis enables a quantitative synthesis of data. This involves, for instance, the weighting of studies based on their precision, which is closely related to sample size, with bigger studies having higher precision. Another factor that influences precision is the variability within the sample. In this case, study 1 and 2 have exactly the same sample size, meaning that they will be weighted similarly in a meta-analytic model. Other studies might, however, have smaller or bigger sample sizes and smaller or larger variability and will be weighted accordingly. In addition to weighting, meta-analysis also allows to assess the relative influence of different moderator variables. In this example, consider that apart from infants' native language, factors like whether infants were presented with a male or a female voice, or whether the critical word occurred sentence initially or sentence finally, could have impacted the results. The above example illustrates that meta-analysis is a useful tool to get a quantitative overview of a field. We can estimate the average of the true effect size, which is a more precise measure than can be provided by individual studies. In addition, effect sizes provide us with a gradual measure to evaluate results, as opposed to the yes or no imposed by p-values. We can also weight individual effect sizes according to their precision, going beyond a yes-no description of effects as in a qualitative review. Finally, we can identify which moderator variables explain part of the heterogeneity between effect sizes, something that can often not be deducted from a single study. A second use of meta-analysis is to inform the design of newly planned research. For instance, meta-analysis allows us to do prospective power calculations. Using the effect size and sample size of previous similar studies, we can calculate their likelihood to detect an effect when it is actually there. Using this information, we can decide how many participants we need to test to detect an effect, for example, with a probability of 80%. We can also use meta-analyses to make experimental design choices, for instance, choosing the method that has led to the highest effect sizes previously. Thank you.